Good morning, 12th class. Today I'll explain some important terms to you. Okay, their formula, their units, even definition is very important, and you all are familiar with all these definitions because you have already learned all these definition in physics. Okay, but in this chapter all these definitions are required. Now first of all, that one is Ohm's law. Very easy. I think you know Ohm's law. That one is V is equal to IR. Okay, it means in this one, that one is V is directly proportional to I, where V, this one is I is current, that one is R is resistance, and V is equal to potential difference. So how to define it? Simple. The potential difference across a conductor, that one is directly proportional to the current flowing through it. That one is okay, directly proportional to this one, to the current flowing through it, that is represented by I. So V is directly proportional to I. When you remove this proportionality, for this one is V is equal to IR. One constant is replaced, and that R is a constant of proportionality known as resistance. Okay, now unit of this one is ohm. Okay, in case okay, unit is ohm. Now another definition. This unit is of resistance. That one is R, and unit is ohm. Now second we have, it's a specific resistance or resistivity. Okay, that is represented by rho. Okay, now in this case, simple, that R is directly proportional to L, that L represents length, and inversely proportional to area of cross section. Okay, so either you can write it directly like this, or separately. R is directly proportional to L and inversely proportional to A, and when you remove the sign of proportionality, so then rho is introduced, and this rho is resistivity, or either you can say it's a specific resistance. So how to define it? Simple, that resistance of a conductor is directly proportional to its length and inversely proportional to area of cross section A. Okay, so whatever, if you know the formula, then definitions are same. Okay, now in this okay, now this one is unit of rho. That one is specific resistance. That one is unit of rho is centimeter. This one is ohm, centimeter. Okay, you can again derive it also, because how to derive it? R is ohm, length, you know that unit either meter, centimeter, and A is centimeter square. So accordingly you can find out their unit also. This one is ohm, centimeter. Okay, now suppose in this case, if the length is 1 centimeter and area is also 1 centimeter, so in that case R is equal to rho. So we have another definition also. So it is defined as the resistance of the conductor having a length of 1 centimeter and area of cross section equal to 1 centimeter square. In that case R is equal to, okay, rho. Yeah, rho is equal to resistance. Okay, now another definition, that one is conductance. So previously conductance was represented by capital C, but now, okay, this one is represented by capital G. Keep it in mind, this thing, that one is capital G is conductance. Okay, so this one is G, not C. Okay, मतलब C will मतलब will count also कि चलो C के लिए marks मिल जाते हैं, but learn proper thing. Okay, now this one is replaced by capital G, and this one, conductance, is inversely proportional to resistance. I think you know, more is the resistance, less is the conductivity. Okay, so this one is inversely proportional. Okay, so either it is defined as the reciprocal of the resistance of conductor. Okay, so G is equal to 1 upon R. The unit is also, okay, inversely proportional, or either you can say it's a reciprocal. That one is either it's a ohm inverse, either you can write like this, it's a ohm and omega inverse. Okay, or you can write mho. Okay, and 1 ohm inverse, that one is equal to Simon. This one is capital S, that one is equal to Simon. Okay, now next is very important, that is the specific conductivity, or either you can say simple conductivity. That one is kappa, or specific conductance. That is actually, this one is very small k like this, it's not a capital one. Okay, and that is represented by kappa, and this conductivity is again reciprocal of resistivity. Okay, now just see, this one is the reciprocal of resistivity is called conductivity. So K is equal to kappa is equal to 1 upon rho. Unit is also reciprocal, ohm inverse, centimeter inverse, or either you can say this one is okay like this, and instead of ohm inverse you can write Simon centimeter inverse. Okay, now this one, how to define kappa? Simple, that K, or either you can say that one is conductivity, is defined as the conductance of the conductor whose length is 1 centimeter and area of cross section equal to 1 centimeter square. Okay, that one is basically conductivity. Now in this one, one more term, that one is, I think we have learned something, that one is L upon A. This one is a separate note. This one is L upon A. That one is known as cell constant. Combinedly, you know that previously we have learned R is directly proportional to L inversely to A. Okay, so that one is known as cell constant, and that is represented by capital G. It's a note. Okay, now for this, for conductivity, okay, one more formula we have that you can learn directly, that one is conductivity is equal to conductance into cell constant. So capital G into G star. Okay, this one is cell constant, or instead of this you can write L upon A also. Okay, now two more definition. One is molar conductivity or molar conductance. This one is a symbol of the C. This one is a symbol of, okay, molar conductivity. So it's a symbol of conductivity, M you will write. So this one is molar conductivity, and simple molar conductivity is equal to, okay, that is kappa into 1000 upon C. Okay, instead of C you can write capital M also, because this C is simple concentration. Okay, and you know for concentration we use molarity. Okay, so how to define it? It is defined as the conducting power of all the ions produced by dissolving 1 mole of an electrolyte in solution. That one is known as molar conductivity. I think you know whatever is your electrolyte, but if electrolyte is strong and weak, when we dissolve it into water, so it dissociate into ions. Okay, so whatever is their conducting power, वो कितना conduct कर सकते हैं of all the ions when it is produced just simple by dissolving 1 mole of an electrolyte in solution. That one is known as molar conductivity. Okay, now unit is Simon centimeter square mole inverse. Now next we have, it's a equivalent conductivity. This term, you know, familiar with this? Okay, we have heard this term in normality, equivalent, gram equivalent and all. Okay, so here also it's the same. Now equivalent conductivity, so how to represent? It's a E conductivity, equivalent conductivity. So you can write EQ also. Okay, so this one is equivalent conductivity is equal to K into, okay, 1000 upon CQ, or you can write capital N, because here this CQ, because it's equivalent concentration, and you know equivalent concentration represents normality, and same definition is same. Okay, it is defined as the conducting power of all the ions produced by dissolving 1 gram equivalent of an electrolyte in solution. That one is known as equivalent conductivity or equivalent conductance. Okay, unit is, okay, Simon centimeter square. Okay, this one is Simon centimeter square gram equivalent inverse. Okay, instead of mole inverse it's a gram equivalent inverse. That one is equivalent conductivity, but in this portion molar conductivity is more important as comparison to this. Okay, but both are almost same. Okay, revise or learn all the formulas, because we will do numerical, okay, on these basis. Thank you.